Understanding the rock cycle is like unlocking the Earth's autobiography, revealing the story of its ever-changing surface, from the fiery depths of volcanoes to the serene depths of ocean floor. Rocks undergo a fascinating journey of transformation. In this discussion, we will delve into the intricacies of the rock cycle, exploring the processes that influence everything from landscape to ecosystem. The rock cycle outlines the tactics that remodel the three fundamental rock types, which are the igneous, metamorphic, and sedimentary, from one type into any other. The formation, motion, and alternative rocks is pushed by the means of the Earth's inner warmth, pressure from tectonic hobby, and the consequences of water, wind, gravity, and residing organisms such as humans. The feel, shape, and makeup of a rock mirror the conditions underneath which is shaped, supplying insights into the records of the planet. Rocks have various composition. They are fashioned from minerals with specific crystal structures and chemical makeups. A few incorporate fragments of other rocks. Others are glassy like osmidian. Residing organisms can make contribution too, like coal plant-based carbon. Extraordinary rocks get up from Earth's diverse environments, surface and subsurface. Igneous rocks, an example, solidify from molten mantle or crustal rocks. Underground, they cool slowly, forming granite. If erupted from volcanoes, they harden quickly into basalt. Metamorphic rocks undergo intense heat and strain within Earth without melting, remodeling their structure. When mountains form or land masses uplift, these closed rocks weathers and erodes.
There are three major classifications of rocks, namely, first, we have the igneous rock, second, we have the sedimentary rock, and lastly, we have the metamorphic rock. So what is igneous rock? Igneous rock came from the Latin word for fire, shape whilst warm, molten rock crystallizes and solidifies. The melt originates deep inside the earth close to active plate barriers or hot spots, then rises towards the surface. A hot spot is an area on earth over a mantle palm or an area under the rocky outer layer of the earth called the crust, where magma is hotter than the surrounding magma. Igneous rocks are divided into groups, intrusive or extrusive, relying upon where the molten rock solidifies. We have two main types of igneous rocks. First, we have the intrusive igneous rocks, and second, we have the extrusive igneous rocks. So what is meant by intrusive igneous rocks? Intrusive igneous rocks, when magma becomes trapped deep inside the earth, it can create intrusive igneous rock, also known as plutonic igneous rock. Massive masses of melted rock ascend in the direction of the surface, while a portion of the magma may fuel volcanoes on Earth's surface. The majority is locked underground, where it slowly cools over tens of thousands or perhaps millions of years to solidify. The individual mineral grains have a very long time to grow because of the slow cooling, which causes them to get comparatively big. The texture of intrusive rocks is coarse-grained. Extrusive igneous rock, magma that escapes and cools above to the Earth's surface, produces extrusive igneous rocks, also known as volcanic igneous rocks.
Extrusive igneous rocks. Rocks that extrude igneous. Igneous rocks that is extrusive or volcanic is created when magma cools and escapes from above or very close to the Earth's surface. These are the rocks that form at the edges of bursting fissures and erupting volcanoes. When molten rock erupts on the surface, it is known as magma or lava. When it comes into contact with the comparatively cool atmosphere, the magma cools and solidifies nearly instantaneously. These rocks have an extremely fine grain or even glassy textures because of the rapid cooling, which leaves little time for mineral crystals to form. The quenched lava frequently retains hot gas bubbles, giving the textures a frothy vesicular appearance. Minerals and compositions of igneous rocks. The elements that are most frequently found in the Earth's crust make up igneous rocks are as follows. We have oxygen, silicon, aluminum, ferrous, calcium, sodium, magnesium, and potassium. So, the example of igneous rocks are basalt, pumice, obsidian, rhyolite, scoria, dacite, granite, gabbro, diabase, diorite, pegmatite, and peridotite.
The second classification of rocks is what we call the sedimentary rocks. Sedimentary rocks are deposits of previously existing rocks or fragments of extinct organisms built up on the Earth's surface to form these type of rocks. Sedimentary rock is created when silt is buried deeply and crushed and cemented. Many of the scenic views of the Southwest Desert region are made possible by these rocks, which frequently exhibit root bedding or layering. The sedimentary rocks exist in three categories. These are the clastic, biologic, and chemical. So what is these clastic sedimentary rocks? The constituent parts of clastic sedimentary rocks are fragments of pre-existing rocks that have been loosened by weathering. The names of these rocks are derived from the clast or grain size, which ranges from the tiny clay particles to massive boulders. Clay is the smallest particle, followed by silt and sand. Pebbles are grains bigger than 2 millimeters. What about these biological sedimentary rocks? Living things decompose, pile up, compress, and cement together to generate biologic sedimentary rocks. Coal or accumulated plant material rich in carbon, or limestone and coquina, or rocks composed of marine life are examples of biological sedimentary rocks. And the last one is the chemical sedimentary rocks. When water moves through rock and dissolves part of the minerals, chemical precipitation starts to form, resulting in chemical sedimentary rocks. When the water evaporates, these minerals are eventually taken away from their source and redeposited or precipitated.
Metamorphic rocks. High pressure and temperatures can cause a rock to change chemically and physically, forming metamorphic rocks. Metamorphism meaning to change form. As the granite cools, these conditions frequently cause it to bend, twist, and stretch. In metamorphic rocks, new minerals are formed by the atom-by-atom replacement of some or all of old rocks' minerals. There are two main types of metamorphic rocks: foliated metamorphic rocks and non-foliated rocks. Foliated metamorphic rock. During the process of recrystallization, pressure exerted on a parent rock aligns or foliates the platy or elongated crystals inside the rock. The platy or sheet-like structure that foliated rocks produce indicate the direction of pressure application. Non-foliated metamorphic rock. When parent rocks metamorphose, the individual mineral grains do not align because not all of the minerals are platy or elongated.